In this video, we're going to be looking at negative integer exponents. In 1, it says, in the previous module, we saw as the exponents decreased by 1, the right-hand side was divided by 3. Using this pattern, what do 3 to the negative 1 and 3 to the negative 2 equal? So we have the pattern of 3 squared is equal to 9, 3 to the first power is equal to 3, 3 to the 0 is equal to 1. Well, if we subtract 1 from the exponent, we have 3 to the negative 1. And if you were to divide 1 by 3, we would get 1 over 3. And then for 3 to the negative 2, if we were to divide 1/3 divided by 3, this would be equal to 1 over 9, or we could also write it as 1 over 3 squared. So if an exponent is negative in the numerator, then it becomes positive in the denominator. In 2, it says, write each expression without negative exponents and simplify if possible. Assume all variables are non-zero. In A, we have negative 2/5 to the negative 2, and it says to apply Rule 2. In Rule 2, it states that if we have a base raised to a negative exponent, and the base is a fraction, we can take the reciprocal of the fraction and write it with a positive exponent. So we can say that this is equal to negative 5/2 squared, and negative 5/2 squared can be written as 25 over 4. Negative 5 squared is 25, and 2 squared is 4. In B, we have 6 to the negative first power plus 2 to the negative second power, and we can rewrite that as 1 over 6 plus 1 over 2 squared, and this is equal to 1/6 plus 1 over 2 squared is equal to 4. And now, in order to add fractions, we need a common denominator, and our least common denominator here is going to be 12. So we're going to have 2/12 plus 3/12, and that's equal to 5/12. In C, we have 2 to the negative third power and 3 to the negative 2 power. And I said earlier that if we have a negative exponent in the numerator, that it becomes positive in the denominator. Well, it also works the other way. If we have a negative exponent in the denominator, it becomes positive in the numerator. So we can rewrite this as 3 squared divided by 2 to the third power, and that's equal to 3 squared is equal to 9, and 2 cubed is equal to 8. In D, we have 5 to the negative first power and x to the negative third power. So the first thing we want to do is make both of the exponents positive. So I'm going to write this as x cubed divided by 5. In E, we have 2 times x to the negative 3, and we could write that as 2 times 1 over x cubed, and that's equal to 2 over x cubed. In F, we have 2x in parentheses, all raised to the negative cubed. And the parentheses is what makes this problem a little bit different than E. In E, the 2 was not raised to the negative third power. It was just a coefficient out in front of our variable. Now our coefficient is also raised to the negative third power. So we're going to write this as 1 over 2x cubed, and 2x cubed could be written as 2 cubed times x cubed, or 1 over 8x cubed. In G, we have 2a squared divided by b to the negative 6, all raised to the negative first power. So the first thing I'm going to do is take care of my negative exponents inside my parentheses. So I can write this as 2a squared, and Our variable b has a negative exponent in the denominator, so it becomes positive in the numerator. So we have b to the 6th power, and all of this raised to the negative 1. So because our exponent is negative in the numerator, we're going to make it positive in the denominator, and we can write this as 1 over 2a squared b to the 6th. And all of that is raised to the 1st power, so we don't have to write to the 1st power. And that's our video on negative integer exponents.